Hey guys, in this video I want to review how to solve a systems word problem. Some of these problems are going to look similar to ones that we did last year when we talked about systems. Some are going to be a little bit new types of problems. So let's go ahead and just start with this first one. First one's going to be a little bit of review. So in this first example, we've got a water park that two different classes from two different high schools are going to on a field trip. And so it says the senior class at Adams rented and filled 8 vans and 1 bus with a total of 149 students. And then the classes at Washington filled 13 vans and 2 buses with a total of 256 students. And so assuming that each van and each bus carried the same number of students, we want to know how many students can a van carry and how many students can a bus carry. So for this, I'm going to start with my let statements. So I want to find two things. I want to find how many students per van, so I can let that be my x value. And then I want to find how many students will fit in a bus, so I'll let that be my y value. Okay, from there we're going to write a system of equations. My first equation is going to involve this class from Adams High School. So I said Adams rented and filled 8 vans and 1 bus with a total of 149 students. So that means if there's x students per van, then 8 times x is going to give me the number of students in just the vans. So that's going to be 8x. And then if there's 1 bus, then y, the number of students per bus, we're going to add to that 8x, and that's going to give us the total number of students that went with the Adams class. That would be 149. So 8x plus y equals 149. Washington, they took 13 vans, so that's going to be 13 times x. They also took 2 buses, so that's going to be 2y. And so if you take the number of students per van times 13, the number of students per bus times 2, that's going to give you the total of students that went with Washington, which is 256. And so now I've created my system of equations. 8x plus y equals 149, 13x plus 2y equals 256. Now, you're more than welcome to do elimination on these equations to solve for x and y, but for a word problem, you're also allowed to use your calculator to your advantage. Let's review how we can solve this system on our calculator by graphing. So if you go to your calculator and you go to your graph screen, we can type in both of those equations in standard form and find the intersection point. If your calculator is in function form, which I'm assuming it probably is, because that's the last thing we graphed, to get that in standard form, here's a review. You go to Menu, and then you're going to go 3, 2, 1, 3. And that will put your calculator in standard form from function form. Menu 3, 2, 1, 3. And so our first equation is 8x plus 1y equals 149. So I'm going to type in an 8 for my x coefficient, a 1 for my y, and then a 149. Hit enter. Now I'm zoomed in a bit, so that line is probably way above my viewing window here. So after I graph my second line, I'm going to end up zooming out, but I'm going to go ahead and graph my second line as well. My second line is 13x plus 2y equals 256. So again, in standard form, 13, 2, and 256. And now I'm going to go to my menu 4. That'll allow me to zoom out, menu 4, and I'm just going to click up here in the upper right, because most of my answers for this are going to be in quadrant 1. Okay, you're going to have mostly positives for some of these word problems, maybe a negative here and there. So I'm going to zoom out until I can see the intersection point, which is right there, okay, right around here. So now I can hit escape and quit zooming out. And now if you go to menu 6, analyze graph, and then 4, intersection, so menu 6, 4, that's going to allow you to actually find what that intersection point is. You'll get a lower bound, which just means you can move your cursor anywhere to the left of your intersection point and click, and then drag your box to the right until you pass the intersection point, and you're going to get an intersection point on this graph of 1437. You can also use this, again, as a way to check your answers to your regular systems of equations. So 1437 is my intersection point. And that tells me that a van carries 14 students. And a bus carries 37. Make sure when you're doing your homework over word problems, you're putting labels with your answers. I don't want to see just a point. I want to see something like this. Give me some labels. Okay, moving on to example 2. This is going to be a new type of problem. I call this a mixture problem. And so it says a zookeeper needs to mix feed for the prairie dogs so that the feed has the right amount of protein. Feed A has 12% protein. Feed B has 5% protein. We want to know how many pounds of each type of feed he needs to mix in order to get 100 pounds of feed that has 8% protein. Okay, so for this one we have one feed that's 12% protein, another feed that's 5% protein. We want to mix those together to get this new feed that's only 8% protein. So my let statements are going to be this. I want to know how many pounds of each, and by that we mean each feed. So X can be my pounds of feed A, that's one type of feed, and Y can be my pounds of feed B. Okay, so the first equation I can write is this. I know I want 100 pounds total of feed at the end. So if there's X pounds of feed A and Y pounds of feed B, that means X plus Y needs to be equal to 100. So one equation for mixture problems is going to be just in terms of the amount, okay, the number of pounds or the number of liters, okay, just the actual sheer amount. The other equation is going to involve, in this case, concentration, okay. We want a specific concentration of protein. We want 8% protein in our new feed, okay. Well, feed A, there's X pounds of feed A, and feed A is 12% protein. So what I'm going to do is I'm going to say that 12 times X is going to be my concentration of protein. So for every 100 pounds of protein, okay, 12 of that, or excuse me, for every 100 pounds of feed, 12 of those pounds are going to be protein for feed A. Feed B is 5% protein. So I'm going to add to that 12X a 5Y. That's going to be equal to, we want 8% protein. So that's going to be equal to 8, but that's not going to be my entire equation. We've got the concentration times the weight here. We've got the concentration times the weight here. So that means when I have my equal to, I need the concentration, which is 8, times the weight, which is 100. So for a mixture problem, here's what I want you to remember. That final amount, that final weight in this case, is going to go in both of your equations. Okay, this 100 value right here needs to go both in your first equation and down here in your second equation. Okay, it's important to have it in both equations. So now this is going to be my system of equations. X plus Y equals 100, and 12X plus 5Y equals 8 times 100, or that would be also 800. So now I can go to my calculator and type both of those equations in, delete my old graphs. And so my first equation is just X plus Y equals 100. So 1X, 1Y, and 100. My second equation is 12X plus 5Y equals 800. You could also just type in 8 times 100 here, and that would calculate it for you. And so if you stay with your original zoomed out window, then you won't have to do anything to this graph here, because now I can see the intersection point. So go to menu 6.4 to actually calculate that intersection point, and that tells me my intersection point is 42.9, 57.1. So not exact whole numbers, okay, pretty darn close, but we're getting some decimals here. So 42.9 and 57.1. So that tells me for feed A, I need to mix 42.9 pounds. And for feed B, we need 57.1 pounds. Okay, for example 3, we have Jane. She has $13.25 in nickels and quarters. We know she has 165 coins in all. We want to know how many of each type of coin does she have. Well, we know she has 2 different types of coins. She has nickels and she has quarters. So I can let X be the number of nickels she has, and Y can be the number of quarters. Okay, for this problem, I know 2 things. I know 2 different totals. I know a total in terms of dollar amount, and I know a total in terms of just physical coins. I'm going to start with this physical coins total. She has 165 coins in all. So she has X nickels and Y quarters. That means X plus Y equals 165. My next equation, the total, involves dollar amount. Okay? Well, you have to think, if she has 1 nickel, then how many dollars does she have? Well, a nickel is 5 cents, so if she has 1 nickel, then she has $0.05. So I'm going to take my X times the value of a nickel, which is, in terms of dollars, 0.05, plus the value of a quarter, in terms of dollars, would be 0.25, so 0.25Y. And her total amount in dollars is $13.25, so 13.25. So for this problem, one equation is just in terms of total coins, the other equation is in terms of total dollars. And now I can type those into my calculator. So we have X plus Y equals 165. Okay, and then our other equation, 0.05X plus 0.25Y equals 13.25. Okay, I need to zoom out a little bit to see my intersection point. My intersection is going to be somewhere over here in this region, just based on the direction these lines are going. So if I just click once, I should be able to see it. There we go. And now menu 6.4, my intersection point is at 140.25. So that tells me that the number of nickels that Jane has is 140, and the number of quarters she has, if I can spell quarters, be quiet, Will, is 25. Okay, last problem. We have Louis, who wants to make a coffee mixture. He's going to mix Sumatra coffee, which costs $2.50 per pound, with Colombian coffee, which costs $3.75 per pound. He wants to make 50 total pounds of mix, and he wants to sell that mix for $3.35 per pound, and we want to know how many pounds of each will he need. This is going to be another mixture problem. The only difference for this one is, instead of a concentration, we've got a cost per pound, but it's going to be set up similar to number 2. So we want to know, again, how many pounds of each being the types of coffee will he need. So I'm going to let X be pounds of my first type of coffee, which is my Sumatra, and Y is going to be the pounds of my Colombian. Okay, first equation, we just want to know how many pounds total does he want. So we know we want 50 pounds total. X plus Y has got to give us 50. Okay? My second equation, this first type of coffee, the Sumatra, is $2.50 per pound. The Colombian is $3.75 per pound. We want to sell our final mix for somewhere in between, $3.35 per pound. So we're going to take 2.5 times X plus 3.75 times Y, and we want to get a mixture that we can sell for $3.35 per pound. Okay, and the number of pounds again in our final mixture is 50, so we need to take this 3.35 times 50. Okay, so now let's graph this last set of systems here. So we have x plus y equals 50. And we have 2.5x plus 3.7y equals 3.35 times 50. Okay, and so my intersection point is about right here, so if I find that, it tells me that the point is 1634. And so that means the Sumatra, we're going to need 16 pounds of it, and the Colombian, we need 34 pounds of it. Okay, so anything in this video you didn't understand, feel free to run back through, jot down a question or two. You can also make a comment. If you're watching this on Google Drive, feel free to put your questions in the form of a comment, and I'll be able to see those before you come to class. Until I see you next time, have a nice day. You're all wonderful people.